Hello friends. Today we'll see the concept of linear and non-linear data structure. Means we can definitely see the difference between linear data structure and non-linear data structure. In the data structures, what is a data structure? We can say first of all it is the logical way of storing the data, and it also defines the mechanism of retrieving a data, or we can also say it as to arrange the data in a proper order is called as data structure. It is a logical way of storing the data, and it also defines the mechanism of how to retrieve the data as well. Basically, data structure is divided into two different types. One is linear and another one is non-linear. Our today's video will describe you the difference between the linear data structure and the non-linear data structure. The main difference between linear and non-linear data structure lies in the way they organize the data elements. Lies in the way they organize the data element. It means wherever it is arranged, the way you are arranging it or the way you are organizing it, it is divided into two different parts. It may be linear or it may be non-linear data structure. Next, in linear data structure, the data elements are organized sequentially, and therefore they are easy to implement in computers memory. Like in the array is the example of linear data structure. Data structure which are data elements are arranged sequentially, or we can say it as linearly, where the elements are attached to its previous and next adjacent nodes. It may be attached to its previous node or next adjacent node or element is called as linear data structure. In linear data structure, single level is involved. Therefore, we can traverse all the elements in single run only. That is the big advantage of linear data structure. In linear data structure, single level is involved. Therefore, we can traverse all the elements in a single run only. Whereas, as far as linear data structure is concerned, they are easy to implement. Linear data structure are quite easy to implement as compared to the non-linear data structure. So, linear data structures are easy to implement because computer memory is arranged in a linear way. The examples of linear data structure are linked list, stacks, queues, arrays, etc. In nonlinear data structure, a data element that can be attached to several other data elements It means there is no any linearity, no any sequence. It might be a single node, a single element can be attached to n number of different elements as well. In a non-linear way, in a non-structured way, that is the reason they are called it as the non-linear data structure. A data element can be attached to several other data elements to represent specific relationship that exist amongst them. Due to this non-linear structure, they might be difficult to implement as compared to linear data structure. Data structures where data elements are not arranged sequentially or linearly are called as non-linear data structure. It is non-linear data structure. In non-linear data structure, single level is not involved. Therefore, we can't traverse all the elements in the single run only. Non-linear data structures are not easy to implement in comparison to linear data structure. It utilizes the computer memory efficiently in comparison to linear data structures. Selecting one data structure type over the other should be done carefully by considering the relationship among the data elements that need to be stored. The examples of nonlinear data structures are trees and graphs. We'll see it in detail. See, Now we'll go into the linear data structure, the examples of linear data structure one by one. Array, stacks, queues and linked list belongs to linear data structure. We'll see each and every type of this linear data structure in brief right now. An array is a collection of homogeneous type of data elements, in which array is consisting of collection of elements. We can represent array by using this, like similar data type. If we can take integer as a data type, it carries all the similar data types in a particular single list of elements, called it as array. Second one is stack. A stack is a list of elements in which an element may be inserted or deleted at one end, which is known as the top of the stack. In stack, only one end is operational, that is the top end of the stack. Stack is open at one end and closed at another end. The element which is inserted into the stack first should definitely exit at last, or the element which we are going to insert into the stack at last should be removed first. So stack perform these two operations. The operations are push and pop. Push is used to add an element into the stack, where pop is used to remove an element from the stack. This is the pictorial representation of the stack, or stack representation. We can say it's the top is always at the top of the stack, where we can perform these two operations. It may be insertion, it may be deletion from the top of the stack. Third linear data structure, we can say it as queue. A queue is a linear list of element in which insertion can be done at one end, and which is known as front end, and deletion can be done at another end, called as rear end. The queue follows first in first out type of property. So whatever the element we are inserting from the rear end, whatever the element we are inserting from one of the end, the element will be deleted from the other end. The insertion can be done at front end, whereas deletion can be done at the rear end as well. Representation of queue is like this: 75 is entered first into the queue, then 65, then 55, and so on. So ultimately the deletion takes place from the front end, so we can say it as 75 will exit first, then 65, then 55, and so on. Fourth linear type of data structure is linked list. A linked list is a linear collection of data elements. It has two parts. One part is the information and another part is the link part. That information part gives information and link part gives the address of the next node. The representation of linked list is like this, in which say 2, 6, 4, 2, 4, 6 and 7 are the data values or elements. Along with that, the node is divided into two different parts. As we know, in first part it is having the actual value, and in another part it is having the address of the next location. See, 2 carries the address of the next location, that is 2184 is the address. It pointing towards the next location where 2184 is located. So that link or the connection goes to the next pointer, that is 4. 3225, 4 carries the address location or address of next location, that is 3225, which belongs to the value say 6, and so on. Accordingly, the way of representing this is called as linked list. Now comes to the non-linear data structure. The non-linear data structure belongs to, or we can say it is divided into two different types. They are trees and say graph. What is tree? In computer science, a tree is a widely used data structure that emulates a hierarchical tree structure with a set of linked nodes. The nodes are somewhere linked to each other with the help of edges. The representation of tree is like this. See, this is the tree where 50 is called it as the root node. On the left hand side of 50 there is element 17, On the right hand side of the tree, there is element say 72. In this tree, the root node or the right side of the root node is having the values or elements which are greater than the root node, and on the left side of the root node, which are having the values are which are less than the root node. This is the representation of tree. The next is graph. A graph data structure may also associated with the age, which associate to each age some age value such as symbolic label or numerical attribute. It may be cost, it may be capacity, it may be length, etc. So the representation of the pictorial representation of the graph is like this. In that case, if we say that the in linear and non-linear data structure, the linear data structure is in which the single level is involved, whereas in non-linear data structure multiple levels are involved. The implementation of linear data structure is quite easy in comparison to non-linear data structure, while the implementation is quite complex in non-linear data structure as compared to linear data structure. Next is in linear data structure, data elements can be traversed in a single run only, as we have already mentioned, and in non-linear data structure, the data elements can be traversed in a single run only. In linear data structure, memory is not utilized in efficient way, whereas in non-linear data structure, the memory is utilized in an efficient way. The applications of linear data structures are mainly in application software development, whereas in non-linear data structure we can use it for the artificial intelligence as well as certain amount of image processing part as well. So this is all about the difference between the linear and non-linear data structure. Thank you for patience hearing.